Hello everyone, in this video I will talk about sorting an 1D array using minimum selection method in C. First I create a C file and I include studio.h and I define size 50, which is the maximum size of the array inside the main function. I wrote commands that we can consider them as titles of the main parts of our code. And finally, I return 0 since the type of main function is integer. First, I will scan the size of the array, then I will scan the array, then I will print the array before sorting, then we will sort the array, and finally, we will print the array after sorting. I will pause the video now to write the simple parts of this code, and then we will think about the algorithm of the sorting by minimum selection, and we will write the code and we will see animation. First, I declare integer I and integer n, which is considered the size of the array, and array t of size 50, as I previously defined. And in the scanning the size of the array, I used do while and printf enter the size of the array and scanf integer and put it in the variable n. And of course, the code will repeat while n negative and while n is greater than 50. In scanning the array, I simply use the for loop. And I loop from I equal to 0 till n I plus plus scan an integer and put it in t of index I, and printing the array before and after is the same. I use the for loop and I loop from I equals 0 till n I plus plus printf integer t index I. Now the sorting code. Let's think about the algorithm first. Consider this array of size 4, then the index will be 0, 1, 2, 3. Definitely it's not sorted. There is many and a lot of algorithm as a human being can you think about. But I think many of you would think to put the first minimum in the first position and the second minimum in the second position and so on. You can easily figure out that 1 is the first minimum and at the first position there is 8. What I will do with 8? Definitely I will not throw it. Then I will swap. Then I will have 1, 4, 8, 2. Now forget about the first position and and now we are in the second position. We want to put the second minimum. How to find the second minimum? As I said, forget about the first position and now consider the array like this and find the minimum, and it will be in the total array the second minimum, and the minimum here is 2. Then I want to swap 2 and 4. Then 1, 1, 2, 8, 4. Repeat 1, 2, 4, 8. And I got a sorted array. And you can easily notice that maximum automatically replaced in the final index or in the final position. Okay, I'm saying first position, second position, then definitely I'm looping on the array. I'm searching for a minimum, so then also I have another for loop inside the first for loop. I'm swapping, then I will use AUX. Then let's start writing the code. Definitely first I will declare a variable j for looping, AUX for swapping, and position of minimum or p minimum for searching for the minimum. And let's start. I will use for yes with variable I. I will loop from I equal to 0 till n minus 1, y n minus 1, since as I previously said, that the maximum automatically replaced at the final position. I plus plus, I will initialize the position of minimum equal to I. Then I will write the second for loop with variable j. I will loop from I plus 1. I will talk about this in the animation. Till n, I want to search for the minimum till the end of the array. And I will say if t j is less than t minimum or tp minimum, then I will open curly brackets. T minimum, the position of minimum is at j, simply. Then I want now to swap. I will say if p minimum does not equal to I, as if I'm saying that if the computer enter to this if statement and open curly brackets. In swapping, I use AUX and I start with AUX and end with AUX. AUX equal T. I want to swap the minimum with the I, the number at index I, T I. The last thing I write in swapping, I start with it in the new line, Control C, Control V, equal T minimum. Then the last thing I write, Control C, that I start with it. Sorry. So let's apply this code to this example. The I is at 8. I will compare 8 with 4. The 4 is less than 8. Then the position of minimum now is at 4. I will compare it with 1. Then the position of minimum is at 1. I will compare 2 with 1. Then 2 is greater than 1. Then the position of minimum is at 1. I will swap 8 and 1. Now I moved from the first position to the second position. Then the position of minimum is reinitialized to be at I, and I is now at 4. Then the position of minimum now it's at 4. I will compare it with 8. 8 is greater than 4. Then the position of minimum is still at 4. I will compare it with 2. 2 is less than 4. Then the position of minimum now it's at 2. And I will swap ti, which is 4, and the position, the t of position of minimum. Then I will swap 4 and 2, and now I will be at 3. The position of minimum will reinitialize at to be at I, since in every loop the position of minimum is reinitialized to be at I. Okay, the I is now at 8, and the position of minimum at 8, I will compare it with 4. 4 is less than 8, and then the position of minimum is at 4, and I will swap. I loop will not continue since it will reach till n minus 1 only. Now let's clear this and try to compile. The computer asked me to enter the size of the array, and I choose 5, and I enter the array 5, 4, 5, 6, 1, 2, the array before sorting, and the array after sorting, it's 1, 2, 4, 6, 4, 5, 6. Then our code is right. Now we will see the animation by this video. First, I is at 64. We will start to compare it with 25. Then the position of the minimum is at 25. Then we will compare 25 with 12. Then the position of minimum now it's at 12. Finally, we will compare 12 with the 11. Then the position of minimum is at 11. Then we want to swap the 64 and the 11. Now we will forget about the first minimum, and I will move to the 25, and the position of minimum will reinitialize to be at 25, the second minimum, and we will start to compare 25 with the 11. Sorry, with what? With that 12. Focus and try to know what is going on. So this is the code. It will be in the description box. Try to understand. I know it's not easy. It's hard. It's complex. But try to understand. Definitely you can. And thank you for watching. Bye.